We're going to do a little synthetic division. This is a special case of division where we can use kind of a more efficient method. But what we're dividing by the x minus 4 has to be linear, which means a degree of 1, and it has to have a leading coefficient of 1, the number in front of x. So in this case, indeed, x minus 4 has a degree of 1, x to the first, and its leading coefficient is a 1x. There's a 1 in front. So we can use this technique. Now, the x minus 4 I want you to think of as x minus c, a number. And that number, whatever it is, c, we're going to take, in this case, it's a 4, and put it in a small box. Okay, that's your number c. In this case, it's 4, positive 4, even though it's x minus c, because we're minusing a positive 4. After that, we are going to focus on what we are dividing into. And we're going to take the coefficients 3, negative 7, negative 22, and 8. And we are going to write those numbers down to the right of the 4 in a row, neat, organized, and professional. Now we're going to start the process of division. The first step is we're always going to start with the first coefficient, and we are just going to add that down. 3 plus nothing is 3. Okay? That answer, the 3, we are now going to take our 4 and we are going to multiply it by the 3 to get 12. We go up to the next column, and now we add again going down, and we get 7. We're going to repeat this process all the way through. So 4 times 5, we're multiplying, we get 20. Now we add negative 20 and 22 and 20 and get negative 2. We multiply 4 by negative 2, and we get negative 8. And this question works out great because when I add, I get a 0. That's great because the last number, the last column, is going to be your remainder. And if there's a remainder of 0, that means that in the original, the polynomial gets divided by x minus 4 evenly. So x minus 4 is a factor. Now, let's just talk about what do these numbers in the bottom mean, the 3, 5, negative 2, 0, that we got for an answer. Well, we started with a cubic function, 3x cubed minus 7x squared minus 22x, and we divided by a linear function. So if we divide a cubic by a linear, a cubed by a first power, you're going to end up with a squared term left, or a quadratic. Okay? So therefore, that tells me when I do my synthetic division, these numbers that I get, the 3, 5, negative 2, 0, are going to make a quadratic for an answer. Okay, so that means it's going to have an x squared to start with, and we know that that coefficient is going to be 3. The next number will have a coefficient of 5, negative 2, and obviously when the remainder is 0, we don't have to write that down. So we take those coefficients and we can write down our answer. So we have 3, 5, negative 2 for our coefficients. 3x squared plus 5x minus 2 matches the numbers I got with my synthetic division, and therefore I have my result. We're going to divide by x minus 9 in this second problem. Again, we need two conditions to use synthetic division. It's linear, which is correct. It has x to the first power, and the leading coefficient, the number in front of x, since we have 1x, is just 1. So we can use synthetic division on this problem. Awesome, it's a little more efficient. Let's go. Again, in the box, we pretend that the x minus 9 is really x minus c, a number, and c goes in the box. So 9 goes in the box. Even though it's minus, a positive 9 goes in the box. Now we're going to take the coefficients. 1, negative 14, 51, and negative 54. We write those to the right, and here we go. Here's our method. The first four coefficients gets added down, so we have a 1. Then we take 9 times 1, 9. Now we're going to add again. Right? That 9 times 1 is 9. We add, we get negative 5. 9 times negative 5 is negative 45. Get 6. 6 times 9 is 54. And awesome, we get 0. Okay? Now, that answer is going to be a quadratic because we started with a cubic. And when you use synthetic division, your answer is 1 degree lower. Okay? So again, we divided a cubic, x cubed, by a linear term, x. When you do that, x cubed divided by x, you get a quadratic. That's how we know how to write our answer. And our final example for synthetic division. Again, x plus 2 we're dividing by, so it is linear. The x to the first is linear, and the number in front of x is just a 1x plus 2. Okay? That's awesome. Great method. Let's go. Okay, now I want you to pretend that the x plus 2 is x minus c, or x minus negative 2. Therefore, in the box this time goes a negative 2. Right? So if it's a plus, it becomes negative in the box. Now we're going to take those coefficients, 2. Now, you would think the next number would be negative 3, right? Nope. Got to be careful because we're missing, in standard form, there would be a fourth power. Right? There should be something with x to the fourth, so we need a placeholder. If you are missing a degree, you put a 0 in. So I have a 0 in as a placeholder. Now I can go to the negative 3. I can go to the 4, and then hold on, folks. Hold on, folks. Again, after the x squared, there should be an x. Right? But there is not one there. So we need to put a 0 down again, and then the 20. Draw a line, and here we go with our method. Bring the 2 down, the first coefficient. Negative 2 times 2 is negative 4. 0 plus negative 4 is negative 4. Multiply by that negative 2 again, get 8. Add 5. Okay, and as we work through, we're multiplying by negative 2, and we're adding. Okay, so 0 plus 12 is 12. Then we get a negative 24, and this time when we add, we didn't end up with a 0, which means, guess what? We have a remainder. Okay, so we have to make sure we understand how to write our answer with a remainder. Okay, again, we started with a fifth power. And when we do synthetic division, we are dividing by a term x plus 2, which turns it into a quartic. So my first coefficient is x to the fourth, 2x to the fourth minus 4x cubed plus 5x squared minus 6x plus 12. Now, include in our answer, we write the remainder, we add the remainder divided by the x plus 2, what we were dividing by in the beginning. So that would be our full, final, correct answer. Okay, synthetic division is a much more efficient method. Here we go.